friends, welcome back to your channel JEE Physics. So we are continuing our journey of the solution of JEE Advanced 2026 paper 1. So this is question number 5. Without wasting any more time, let us discuss. So here they are saying that consider a hydrogen atom with Vk, Rk and Kk denoting the velocity, orbital radius and kinetic energy of the electron in the kth orbit. The electron undergoes transition from nth orbit emitting radiation corresponding to Lyman series, that is n equal to 1. Considering h to be Planck's constant, you have to verify these options. Now this particular question is quite a lengthy question. It seems to be easy, but if the process flow of solving this question is not correct, then you will get stuck. It will waste your time. It can degrade your morale also. First, as usual, I will encourage pause the screen, try your own. If you get stuck while trying on your own, then only refer to the solution. Otherwise, there is no need to look at the solution. So now let us proceed with this. So the first thing is that we will follow Bohr's quantum condition. So what is Bohr's quantum condition? That is simply mvr, that is equal to nh by 2 pi, where h being the Planck constant. To cut it short, sometime we write nh cut also, h cut being the Dirac constant and h is the Planck constant. So anyway, so you come to this. So here we can write mv. mv is equal to how much it is coming? nh by 2 pi r. If we proceed further, we will multiply with half v on the both sides. So half v into mv is equal to nh. So it will become 4 pi r. Here one term of v will come. Look at the left hand side of the equation. It is nothing but kinetic energy. So k is equal to h into nv divided by 4 pi into r. So from this equation, it is quite clear. If you want to check the change in kinetic energy, so delta k, this value will come h by 4 pi, you take it common. So here it is n into vn by rn minus v1 by r1 mod of this, right? So here basically this is the variable. So we have to put this difference between nth level to the Lyman series means n equal to 1. So option A is verified. Let us go for the second option. They are saying magnitude of change in de Broglie wavelength. So they are asking lambda. Lambda is equal to which? No, h by mv. Now we have to manipulate the data. We know mv square by r is equal to electrostatic force E square by 4 pi epsilon naught r square. So there mv square is coming E square by 4 pi epsilon naught r. Once again, if I multiply with half, so this will become half v square is equal to E square divided by 8 pi epsilon naught into r. Half mv square is the kinetic energy, E square by 8 pi epsilon naught. R value will pick from here. From this equation, we can pick the r value. First, Bohr's quantum condition only. So there r will come how much? R is coming to be nh by 2 pi mv. So here 2 pi cancelled by 4. So the result will go up. So here k is equal to, it is coming E square into mv divided by 4 epsilon naught n into h. So look at the equation. There mv is coming how much? 4 epsilon naught k nh divided by E square. So we will go back to this equation, that is lambda is equal to mv. From there we'll get the clarity. So lambda is equal to h divided by mv. If I substitute this result, what we are getting? If I substitute mv, we are getting E square into h divided by 4 epsilon naught k n into h. H get cancelled, right? So we are getting the result lambda is equal to E square by 4 epsilon naught n into k. This is the value of lambda. Again, we have to check between two levels, that is from n to n is equal to 1. Now let us come to question option 2. So option 2, E square by 4 epsilon naught, answer is matching. But here you see, if you closely look at this, it is only kn, whereas we got n into k. So that is a thing that is missing. So that means here option B is a wrong option. Next, they are talking about frequency of the radiation emitted. So for the frequency of the radiation emitted, energy E, we have to simply substitute H into nu, that is the frequency of radiation. So K, kinetic energy, is equal to how much we got? K is equal to, we got here, K is equal to E square by 8 pi epsilon naught into R. All of you must remember that kinetic energy is numerically equal to total energy. Magnitude of this. Kinetic energy is E naught, total energy is minus E naught. So I can directly substitute this result, that E square divided by 8 pi epsilon naught R is equal to H nu. So if I go back here, frequency nu is coming to be E square divided by 8 pi epsilon naught H into R. This is going to be the equation for the frequency. Since it is taking place between two levels, so you see, we can directly write this as difference in energy E square by 8 pi epsilon naught into H 1 by Rn minus 1 by R1. So yes, as per this, option C is also coming correct. Option C is coming correct. Next, magnitude of total change of the electron can be expressed as. So please, as I said, magnitude of the total change in electron energy, as I told you earlier, if you look at these data, magnitude of kinetic energy is equal to total energy. I am telling once again, if kinetic energy is equal to plus E naught, potential energy has to become minus 2 E naught, then total energy will become minus of E naught. Total energy has to be negative, that is for bound particles. For any particles which is bound, total energy has to be negative. So that means change in total energy must be equal to change in kinetic energy. So that means, as per the options, option A and D should have been the same, but here D is different. So D is also not the answer. I hope you have enjoyed the solution. If you have enjoyed, then please do like, share and subscribe. Thank you. See you in the next video. Bye-bye.